So if we balance this equation, we'll get 2 HGS plus 3 O2 gives you 2 HGO and 2 SO2. And further, if you continue the heating, 2 HGO. So what will happen, everybody? So this is, let me take step 1 and the step 2. So if I am further heating, who is that? Please mute yourself. If I am further heating, continuing the heating, I will directly get the pure liquid mercury, Hg, liquid mercury plus oxygen gas will be go outside. So this is how we can, the low reactivity, like this is what less electropositive elements, for them, it is not necessary that the reducing agent is required. Directly they can be extracted by heating itself. So this is one of the example. Of course, we can study again low reactive metals, high reactivity metals. So you all people know reactivity series. Keep it in mind, if you are keep on going down, now I am saying you, the electropositivity will decreases. If you are keep on going from sodium to gold, okay, everybody. So electropositive nature will be decreases or increases? Electropositive nature decreases. Keep it in mind. That is very important. So that less electropositive metals are present here. More electropositive metals are, like high electropositive metals are present and middle moderately electropositive elements. That is what it is. Okay. So now second process, chemical reduction. So one is self-reduction. Second process is what? Chemical reduction. So here, if you notice it, under the chemical reaction, definitely we need to use what, guys? Reducing agents. So what is the best reducing agent we people used to prefer? That is what? Carbon. What is the reducing agent we'll use it, guys? Carbon. But carbon in form of coke or coal. Understanding? So coke or coal, both are forms of carbon. Okay. So that is why we will use a carbon in the form of coke or coal as a what? Everybody. As a reducing, please respond. As a reducing agent for moderately reactive metal oxides. Keep it in mind. So as a reducing agent for moderately reactive metals. Can you tell me what is the moderately reactive methods in our period, that metal activity series? Moderately reactive metals. Yes, please.
Zinc, iron.
Yes. Zinc, iron. That's all. You can take it. What else?
Aluminum.
Yes. You can take that also. So aluminum also. So aluminum is highly reactive only, basically. So we'll go with the zinc, iron, lead, and copper. So this kind of course, copper is under least reactive, less reactive also. So, but basically we'll say reduction using a carbon. Basically, we can take two. One is zinc and as well as what? Zinc and as well as iron. So that two alone we will take it. So what is the oxides? Oxide ores of zinc and iron. Both everybody tell me. Zinc oxide. See that as a reducing agent for moderately reactive metal oxides. Moderately reactive metal oxides. So zinc oxide, tell me, what is that? Zinc oxides reacting with the carbon. So it will form what? Heat form zinc plus carbon monoxide gas. Next, iron, Fe2O3. What is that ore? Tell me. Ferric oxide. Yeah, reacting with the carbon. Okay, which will start heat so that it will form Fe plus carbon monoxide. Can you balance this equation? Second equation, boys, girls, anyone? Arun, Kaushik? Try at least. If you try only, you can. Simply sitting, nothing is going to change in our life. And that's, I'm very particular in that. Please make sure you're trying something. Make it quick, all of you.
3 Fe2
3.
3C.
Fe2O3.
3C plus
2
Fe plus
Fe plus 3C.
that's what. So see, now different people are trying. That's what is great. If you are involving, if you are doing it only, everything will be fine. If not, it is very tough. That's what I'm saying. So please make sure that you're doing something. Make it fast, everybody. So that's all it is all about chemical reduction. So on next one, the familiar process. One of the decomposition reaction. Second type of decomposition reaction. Anybody can tell me types of second type of decomposition reaction? Yes, please. Electrolytic reaction. Okay. So electrolytic reduction. So this is what one of the reaction, but electrolytic reduction will get two reactions. What is that? Everybody, cathode one reaction will take place. That is what we will say cathodic reaction. And another one is what? Everybody, anodic reaction. So at cathode one reaction will take place and anode another reaction will take place. So keep it in mind, cathode means positive or negative. Cathode means negative charge and anode means what? Everybody, positive charge. Understand? And cations. What do you mean by cations? Positive or negative? Everybody.
Positive.
Cations are positive charge and anions are negative charge. So anions will go always towards to the anode. Cations will go towards to the cathode. So for electrolysis reduction, it is applied for all the highly reactive metal oxides and halides. So electrolysis process is applied for what? Everybody? Applied for all the, yes please, highly reactive metals, metal oxides and as well as halides. So halides means one of the example in the tabular column. Yes please, sodium chloride. Am I right or wrong? Guys? Yes, please respond. That is what. So what is the highly reactive metals? Check it everybody. Sodium, potassium, calcium, magnesium and aluminum. So till here we will say highly reactive metals. So for these metals we will use what is the technique to separate everybody? What is the technique? Electrolysis process. Okay, so that is what you have to remember it. And there is the metals which are always found in native state. What do you mean by native state? Native state. Native means what? Yes, pure form. Native means pure form, no impurities. What is the metals in the periodic table? Sorry, in the metal activity series. Silver and
Gold, sir.
silver and gold. So silver and gold we used to call native state. So means already they existed in the pure form. So that is what you have to remember. Okay. So now this electrolysis reduction we will use it for the highly reactive metals. So that when we are studying that processes, we will study the chemical reactions. But here we have to study for electrolysis reduction, cathodic reaction and as well as anodic reaction we have to study. Now, during this process, you remember, metal is always obtained on cathode. During this electrolysis process, during this process, note it everybody. The pure metal is always obtained at where? Everybody? Pure metal is obtained on cathode. Because cathode is a negative charge or positive charge? Negative charge. So that cations will come because cations are positive. So that is what it is. Always it will be. Is it okay, guys? All of you? Yes? Yeah. So this is what? We will use different things like refining of metals. So this is what the third step. What is the third step? Conversion of oxides into metals. So based upon the reactivity, either self-reduction or chemical reaction or electrolytic reduction. That's all we will choose it. So after that, what will happen? Again, further purification. Still, there is some impurities will be there. So that is what the last step of purification. That is what we used to call it as what? Everybody? Refining of the metals. So complete, you will get a pure metal in this. So here, refining of metals is the process of purifying the impure metals. Please note it. It is the process of purifying impure metals. Okay. So here also the best method which we people will use to extract the pure metal from impure metal is electrolytic method. Understanding everybody? So again, the two reactions will come. Whenever you will get electrolytic method, again two reactions you have to write it. What is that, everybody? One is reaction. Another one is what? Anodic reaction. We will study the example. But I will say you, here refining of the metals, cathodic reaction and anodic reaction, standard equations I will say you. So please learn it. Most important one. Many times they will ask you this one. Based upon this, 100% there will be a question. So if it is a metal, pure, already we got the pure metal, but it is impure or pure? Impure metal. So we have to purify it. So metal, if I take metal atom, this is metal atom, anodic reaction. So it will form Mn plus, that is what it will turns into metal ion, plus we will get number of electrons is, electrons will be coming outside. Now these electrons, so cathodic reaction, what will happen means, all of you remember, cathodic reaction. These metal ions will come to the cathode, metal ions, okay, which are in aqueous state, and they will react the electrons and they will turns into the metal, again metal atom. So that is the process, cathodic reaction and as well as anodic reaction will takes place. So please make it. At the anode, they will lose the electrons, and at the cathode, they will gain the electrons and they will turns into that. That is why I said, where will get the pure metal? At the cathode or anode? Everybody. Pure metal is always obtained at the cathode. That is what. So you have to make it. Okay. And insoluble impurities are separated out in the form of anode mud. We will study that. Okay. The impurities which are separated, which will come under the anode, that impurities is only we used to called as what? Impurities, which we used to called as anode mud. Okay. So we'll study that process. You don't need to worry. That's why pure metal always gets collected on what? Everybody? Collected on cathode. For class 10th, we have only electrolytic method for refining of the metals. Okay. But there is many methods in chemistry, like we can use a purification of metal. That's what refining of metals. We can use extract liquefaction metal. Okay. So like particularly the impurities when purified as if you notice it like bismuth, lead, tin, this kind of metals, we will use it by using liquefaction. We will use it electrolytic refining. So this is the one basically we'll use it. We will use distillation process. 9th class we will study distillation. Do you remember everybody? We will use oxidation technique and we will use many things, where for zone refining, like this, many names, many techniques we have for extraction of, refining of metals. Means pure metal, already metal we obtain, but still it is also having impurities. That extraction of pure from impure metal, the process of purifying the impure metal, we have many techniques, but only one technique we will use it for class 10th, which is most important one. That is what? It is what? Only you have that. That is only called as electrolytic method. Understanding all of you? So electrolytic method, based upon that, there will be a concept in our book also. That is the most important one. So tomorrow onwards, we will study which metals will undergo electrolysis and what is the techniques, what is the process, which metals undergo reduction by using carbon. We can use it either carbon or we can use it as a what? Everybody, aluminum. But that carbon also will use in the form of what? Carbon is used in the form of coke or coal. Okay. So that is what. And then we all people are very familiar with this. What is it reactions called as? Thermite welding. All remember? Thermite welding means this both equations. Thermite welding. Next one. This is what I said just now. So anode and cathode. So the impure extraction of refining of pure metal. Refining, like purifying the impure metal to pure metal. We are having only class 10th. We have only this technique, electrolytic refining. So refining of metals. So the impurities which are obtaining below the anode, what is to call anode impurities. Understanding? Everybody? So as I told you, at the anode, they will lose the electrons or they will gain the electrons. At the anode, check it everybody. At the anode, they will lose the electrons. Understanding, Amma? So that is what at the anode. Sodium means it will lose the electron. That's why I made it as a standard equation. Please remember that. What is the anodic reaction? Metal is undergoing loss the electrons. Understanding? Mn plus. That is what it will turn. So Mn plus and plus electrons will come outside. And at the cathode, what will happen? It will gain the electron. That is what? This is cathode reaction and the anode reaction. So at anode, they are going to lose the electron. At the cathode, they see that they will lose the electron, they will turn into what? Positive ions or negative ions? Everybody. They will turn into ions. These ions, they will move towards the what? Everybody. Cathode. And here again, they will obtain the electron and they will be converting into pure metal. That is what it is. So that one, Mn plus, okay, react with again electrons and it will turns into M. That's what metal atom. So that is what reaction will takes place. Okay, so please learn that. So what is the reaction is carrying out? You have to know here very clearly. So impede cathode reaction as well as at anode reaction. Of course, we'll study that. Okay, so from here we'll continue next class. So next corrosion, this is over means then the concept called as corrosion is required. So this corrosion is also one of the most important. Once it's over, then prevention of corrosion. Already first chapter we studied. Once it's over, this chapter is completed. Hardly this week, mostly within 2-3 days, we'll finish this concept. Okay. So this is all about it. I hope you all understand. Anybody is having any doubt, you can ask me, or else you can leave from the meeting. Thank you, everybody. We'll meet in tomorrow's class. Get back to work and read. Get back to work and read, everybody. It's not easy that these last concepts are very important, very, very confusing concepts. So please show interest and work. Thank you, everybody.